Hey mate, I thought I'd do a video and I'll send it to you with overlaying everything that's just happened.
Hi guys, in this video you're going to watch me and Tom sort out his dodgy tack welds. I love that word.
Hey mate, I thought I'd do a video and I'll send it to you with overlaying everything that's just happened. So it's just easier than you having to open each and every document and then whatever. So started out with showing you the picture of the tungsten,
Looking good.
and that was fine. Like the stick up seemed to be good. And then I balled the tungsten and then I put tacks either side. They were both fine. I didn't have an issue with the two tacks.
Yeah, and the reason that the ends are always easier for everybody is, let me draw this out. So if you're looking at this, and I'm going to use standard measurements. Sorry, I'm not familiar with metrics right off the top of my head. I'd have to look them up. So 1/8 of an inch, right? And then, so if you're measuring from here to here, that is like, an 1/8 of an 1/8 of an inch, if that makes sense. And then if we have this top piece on here, draw that, that is also an 1/8 of an 1/8 of an inch. So it's really thin material and it liquefies together at the same time real easily versus if you have, especially if you have the base plate on another metal piece, especially aluminum, when you start trying to tack weld these together out here without filler rod, all that heat is going to make this liquefy way quicker because of that thin little sharp corner. And then this one on here, the aluminum has such high thermal conductivity, it takes all that heat and spreads it out evenly real quick. So you have to be mindful, like you figured out. We'll tell everybody later in the video, but you got to really focus your heat down on the base plate, be more mindful of that. And you get, it comes to you real easy after doing it a lot. It'll click, and then it's like mindless. You just do it. You just start looking at the puddle, and if the puddle's up here, just immediately get down lower.
That tacking was done. So the settings for the machine is this is a 200 amp welder.
Okay, 200 amp welder. On second thought, I'm gonna do the right thing and do this in metric since you're the one giving me this great video idea. I appreciate it, Tom. So what I'm doing 3mm thick sheet. I can't remember what you told me, sorry, in our previous text messages. But for this, you can get by with 200 amps. But like I showed you, I don't know if you noticed the text in the earlier, when I started tack welding, I bumped it up to like 235 just to get that speed and that heat in there quicker, like you say, later in the video that it clicked for you. That's what you want to do. And you can get by with like a 180 or 200 amp welder welding this type of stuff. But in a production scenario, you're really going to wish you had more amperage so you can just punch in and get the tacks going real fast and not let the heat all start soaking out everywhere and get the part too hot.
And so I did the two tacks, 180 amps, and that was fine. That was no issue. And then I tried to do the center tack, and I just blew right through the top and didn't really melt the bottom. I couldn't get the balance between the two right. And the look of the tungsten after was terrible again. So I had to reball it, had to change the balance on there, reball it, change it back again, tried again, and then it finally worked. I did it on the other side and slightly out the way. Had to reball it again. These are 2.4 millimeter Unimig zirconiated tungsten. It says AC only. This is apparently the ones that you want for AC.
So I've tried a lot of different types of tungsten, diameters and, you know, composition, lanthanated, serrated, zirconiated, blah, blah, blah up here. And that one, you'll have to go back and check out my website, Tom. That is not the stuff that I recommend, and is for only aluminum, which I don't know. That to me, that means that it doesn't work good on steel. And the one that I tell you I recommend on my website works great for everything, and it holds its shape good. So I don't know if that's your problem or the welder. Like, you know, I can't tell you without trying that welder out myself and doing back-to-back tests, but I would strongly recommend you use the diameter and type of tungsten that I recommend on my website and do a back-to-back test with identical weld settings and that, and do a bunch of restarts and stops, get your heat up quick, you know, and try to see if you can liquefy it and distort that tip and see if that solves your problem. And I'll tell you a quick story about when I started, you know, like 20 years ago or whatever. Miller's website recommended to use pure green tungsten for aluminum, and that was some of the worst advice I ever got in my life on TIG welding. So pure tungsten, it's horrible for DC welding, and they say it's good for AC, but I think it's even worse for AC. That junk does not hold its shape, and, you know, luckily for you guys, that myth went out the window. I fought that dang suggestion for like 1 or 2 years, and I was wondering why my tungsten wouldn't hold its shape, and, you know, my arc was wandering everywhere, and it was nearly impossible to do good repeatable welds with that junk. So, and also I've noticed with different brands, there's a welding supplier online, I'm not going to name them, but I finally got it out of them, that if you get the same type of tungsten and it's like different brands like Miller or X brand, whatever, I've noticed that sometimes you do get what you pay for. They finally spilled the guts and told me that they came from the same mine or whatever, you know, however they mine tungsten, the brands like Miller and the other one of the same type, and they're not the same part number. They're like different, they're produced different or something. So I did a test with them and I noticed that the Miller brand worked a little bit better. It was a little more stable and just seemed like, I don't know, it just worked better. It held its shape better. So think about that, you know, go to my website and check out the tungsten I recommend and buy a high dollar brand if you have any doubts about that stuff that you have. Then your wave balance, I'd have to get like an, what do they call them, an oscilloscope, and hook it up to your machine and see if the wave balance adjustment is honest. Because I've noticed there's a little bit of discrepancy in some machines, you know, like Miller's versus any, you know, like any other brands, I guess. I haven't used Everlast yet, but Prime Welds, AHPs, Lincolns. The wave balance knob doesn't seem to be the same on all of them if you put in the same number. And then like Miller on my website, their balance knobs are backwards. They tell you the percentage is opposite, if that makes sense. But like you were saying, 20%. And on my Miller, I bet if we did like side-by-side tests, I bet that they wouldn't quite correlate on a scope, you know. I might be wrong though. So yeah, tungsten type, get a quality brand, and then you can screw with your wave balance and turn it down below 20 even more, so it doesn't draw as much heat back in your tungsten and liquefy it while you're welding. God, hopefully that wasn't too long of an explanation. I felt like I was rambling. Let me know.
So I had to ball it again after that, but I finally did get the tack in. And then I thought to myself, well, that was just absolutely disastrous. So I upped the amperage from 180 to 200, and I managed to join those two bits much easier. That was at 200 amps rather than 180. It still wasn't perfect, but I'm trying to process everything, but it was much easier. And then it flowed beautifully. I did everything I normally do, but I didn't get this massive horseshoe shape that I tended to get last time.
And the horseshoe he's talking about is really common on T-welds. People have a hard time with this at first. And I'm going to address this. I'm going to make a whole video about this after this one, so stay tuned for that.
I got a little one, and then all of a sudden it just filled. A little one that just filled with a little bit of filler. And so I'm over the moon. I'm so happy. I think what my issue was this whole time was not enough amperage. Because I watched one of your videos. One of your videos you had it at 180. And I know each machine's slightly different. So I was like, right, I'm going to start at 180. I've been at 150 this whole time. I'm going to start at 180 And for you, you know, someone of your skill level, you could probably make a whole huge range work. Obviously, I can't do that. So I was like, all right, well, I'll try and pump it up, thinking I'll probably blow through it. Went up to 200, and it was much easier to get the puddle formed between both. And I kind of started it at one point, and then I kind of tilted it up, the torch up, and I could match it to the other, and then I filled it from there. And the result was so good. I am so happy.
That's great to hear. Those breakthrough moments make you really happy, don't they? It's like, I don't know if anybody plays musical instruments, but once something just clicks, you're like, oh my gosh, now I can go to the next level finally.
I think this whole time, my issue has been not enough heat, and I've been trying to chase blending those two together, and then like the tacks, not enough heat in the tacks. I'm gonna have to try another tack. And then the next thing was that being too cold, you're kind of staying in a place a bit longer, and then I'm moving a bit too quick. And because it's too cold and I'm moving a bit too quick, I'm melting the outside edge, but I'm not really forming and getting everything to flow together. So I'm kind of shoving rod in to get rid of that massive gap that I've formed.
Okay guys, this is going to be some great advice for you, and I honestly don't know if anybody teaches this. I don't think they do. A lot of welding schools will teach you to do, you know, like they practice without filler rod butt welds. Maybe you're just running beads. And they never teach you to practice T-welds without filler rod because you're not supposed to do it. You know, it's not strong. If you're making something, you're going to want to put filler rod in. But I suggest you try doing all the welds without filler rod, because what it does is it isolates your torch hand. And if you can't do this without filler, like, you have to have a really nice tight fit up for it to work, and the right type of aluminum. 6061 will crack right behind you. You can use 5052 or 3003, you know, softer series. If you can't do all these welds without filler rod, then you need to reevaluate how good you are with your torch hand. This will really show you all your mistakes, because you can't blame it on your filler rod hand, because your filler rod hand's not doing anything. So you know this is the problem right here, your torch hand. So check this out. Make sure to push that down nice and tight, or else it's not going to work right. Okay, like I explained in an earlier video, I shear my parts so they have an angle on the top. They're not perfectly square. One side has a little bit of a gap and the other side doesn't. See, that side's got a shadow down in there. This side without the shadow is going to be your easiest one to do. This side is going to horseshoe out because there's a gap, and then you'll have to use filler rod. I can do this without filler rod, but it digs in really deep. I'm going to show you on this side first. Hopefully I get this first try. What I'm going to try to do is show you from the back side, come halfway, and then try to get you a decent arc shot and finish it off. And the problem most people realize they have is they're not driving that tungsten in really close. You know, you want to get as close as you can without touching the puddle. And that'll keep it from horseshoeing and putting heat too far out. It gets that heat right down in the groove. See how the part popped open? That tack wasn't strong enough, so we got a horseshoe right here. So I'm going to heat all this up again and push it back down. And then you can even tap it. You can tap it with a hammer too to set it back in place tight. That's a good example. I'm kind of glad I made that mistake to show you. Okay, now we're back down tight again. I'm going to add a little filler rod on the back just to make sure it stays in place. Okay, I got that horseshoe right there, so that's impossible to fill without filler rod, as big as that is. So I'm going to put a little bit of filler rod on it and then try to do the rest without rod. Okay, I got it filled back in. Now let's try without rod. So all that was done without rod, but you can see it's not a strong weld. See how far that's sinking in? It's really thin. So, and then, you know, depending on what you're making, you may not want to burn through the backside, but that shows you that you're getting good penetration because you're liquefying down in there in that root. So if you want the strongest weld, you know, like, it's okay to get this on the backside, but if you're making parts where you don't want there, you're always gonna want to use rod, like I said. But just, it's okay to get the horseshoe going. Some stuff I've made before in the past where I don't want it to burn through, I've had that horseshoe going, and if you keep it small enough, you know it's not fusing into the root, if that makes sense. Let me grab that drawing again and find it. If you're not fusing down in that root, that's okay for a lot of things, you know, because if aesthetics matter on whatever part you're making, you don't, and this is going to be visible over here, you don't want that. So horseshoeing is not necessarily a bad thing. It can be frustrating though. Okay, anyways, so let's do this one. What was I saying? Let's do, oh yeah, I'm going to show you an arc shot on this side. Try to at least. Okay, hopefully this goes okay. I've got the camera in really close to try to give you a good shot. I might run out of room here at the end because I'm hitting the tripod, but see how it goes. Okay, I'm going to use less amperage and try not burning through the backside on this last portion. See how cold and frosty that is? That's great practice though. And then, like I said, I tried to not burn through the backside on that. That's probably the best practice. That gives you heat control practice, and then the puddle is so small, you have to be super accurate with where you're pointing it to keep it, you know, fusing both sides equally. So if your T-welds suck, give that a try. Guarantee that'll help you out.
But I didn't blow through at all on that time. So I think initially that dodgy tack that I've sent you a photo of, I was too much on the upper coupon, and I had all the heat up there, which is stupid. I should have started on the lower coupon right near that join, the lower coupon, and then moved it up. Anyway, any feedback, it would be hugely appreciated, because I've done, I don't know how many, probably 50 or 60 now, a whole bunch of boxes in there, I've thrown a whole bunch of stuff away as well. And not that I haven't got a tack this nice before, not that I haven't got a weld that nicely before. I have got a couple of them, but they didn't flow anywhere near as nicely at this. So I think the temperature is the issue. One last quick question. As long as I don't go over the duty cycle, is it going to reduce the lifespan of the machine if I'm running it at its maximum capacity?
That is a really good question, and honestly, I'm not the guy to give you an answer on it because I don't know, but I'll try to give you some of my thoughts. So I'm sure it depends from manufacturer to manufacturer. As long as it has like thermal protection and it'll shut itself down with, you know, in a good amount of time before it creates damage or, you know, compromises longevity of the machine, and that's good. But I don't know. I have no idea about this brand that you guys are using down there. I have no experience with them. You know, but they're giving you a 5-year warranty, so they're obviously pretty confident in their product. You know, a lot of machines only get 3-year warranties, other than the big brands. Now I think they're doing 5, like Miller and Lincoln. And then another thing you don't want to do, I don't want to talk trash on anybody, but it was like weld.com way a long time ago. There was a guy that called himself Mr. TIG, and there's a video that cracked me up. He throws down this weld and he's all proud about it, and then he immediately shuts the machine off right after he did this hot weld. You know, you got to give your machine time to cool down. And yours, I think you got the machine on in the background in some of this video. I'm recording right now. I'm not looking at the video, so it seems like it's got a fan on demand. So when you're done welding, you want to let that thing run the fan until it completely cools and shuts its fan off. You know, for longevity of the machine. That's about all the advice I have to tell you. I did have a real cheap welder. I'm not going to name names, but a budget one that got bought on Amazon, you know, like 5 years ago. and I gave it to one of my buddies, and he had 2 capacitors pop in it on the inside. And I don't know if that was related to overworking it or what the problem was, but I just say, run that machine hard and get your money's worth out of it. If they're saying it's going to last 5 years, that's pretty good. Not saying that that's good if you only get 5 years out of a machine. I'm saying that's good that they're that confident that the machines will last that long. But me just trying to think about this and like compare it to any mechanical or electrical thing, the more you use anything and the harder you use it, it typically wears out quicker, like engines, car engines. If you run them at low RPM, keep the temps down and stuff, keep oil change, whatever, they last a really long time. But if you're running them at high RPM, more speed, more friction, more heat, it's going to wear motors out. Top fuel dragsters last 1 run, and the semi truck will go 1,000,000 miles before a rebuild if maintained properly.
Or so what I've got set up is I've got fan blowing in that direction anyway. I will do a run and then I just leave it, for 2 or 3 minutes before I do another one. It is a commercial unit here in Australia. They are used commercially by tradespeople. And it's got a 5.5-year warranty on it. It's incredible, really. But it used to be a 25% duty cycle up there, but now they've changed it because they've put a power correction factor in, and that reduced it by 5% on the top end. So I don't know, but any feedback on the side, running at that maximum amps, is it going to reduce the life cycle? I guess after 5 years, if it's hammered anyway, I've still got good use out of it. But feedback would be much appreciated. It's an Australian company. And I'm using 3.2 mil filler rods. So
if I'm hearing you right, 3.2 millimeter filler rod is pretty thick, but a lot of it comes down to personal preference. Like the thickest I ever use typically, and I explain this all on my website, you can review it, what I prefer. The thickest I ever use is 3, unless I'm doing really thick stuff. Then I'm gonna have to go digging for it under my table. Hold on a second. Let's see what this stuff is. That's 3.75, and then for us inch guys, 0.15 inch. So yeah, this stuff I hardly ever use, but for real thick stuff I would. For what you're doing, I'd suggest try running some thinner stuff and see if you like it. Try them all, personal preference.
So I don't know whether it's worth going down to 2.4, but those tungstens are just really getting destroyed at those higher amperages. So is it worth me going up to 3.2? Let us know. Thanks so much, mate. I'm absolutely loving your online class. Anyway, if you want to use this for a video talking about, I guess, my instance of don't be afraid to use, and I know you've done this before, don't be afraid to use heat, get in there, punch it hard, move, and then get out quickly, because you actually do less, or you create less of a heat affected zone that way. And not that I need to tell you this, but I'm just thinking as a beginner, that I was always reluctant to push it that high, thinking, I'm going to blow through it, until I saw your videos. All right, mate, bye.
Okay, thanks for watching, everybody. That was a pretty fun video for me to make. Hopefully you guys found it helpful. And then a huge thanks to Tom again. Sometimes I complain about YouTube a little too much, I think. Like, it is, if we think about it, he is in Australia and I'm in, western central United States. And he's pretty much as far across the globe as he could be for me, and we're communicating back and forth and learning. I'm learning to become a better teacher through him, and I'm helping him out. And Tom, you're clearly an intelligent, persistent person. You're going to do great if you keep at this. I know you will, because you're really analytical about this stuff like I am. This video was made possible because he subscribed to the website and he contacted me through email. So what do you guys think? The one-time $45 subscription fee for my website, think it was worth it?